here we go, last one. 8.7 function notation.
We're going to talk about function notation. And you're probably used to seeing equations written as y equals maybe x squared plus x, y equals 8x minus 5, things of this nature. The idea is, maybe you have a couple of equations that you have to deal with in the same problem. I always thought of function notation as maybe just somehow being like a name. So what we're going to do, instead of using y, we're going to replace it with f. So it says f of x equals x squared plus x. So I always just kind of thought about f as being the name. And it's not f times x, it's read f of x. So make the careful distinction. This is not multiplication at all. It's just one of those cases of, I think the notation maybe could be a bit better, but this is kind of what we're stuck with, and this is what we use. Whatever the variable is, that's what's going to go inside of here. Likewise, maybe I can name this other function down here. I can call that g of x equals 8x minus 5. That way...
Okay, when we're looking at that, the y equals, right here, the y equals 8x minus 5. What kind of form is that in? Function form or slope-intercept form. So we could have given this one the f of x also, but he'd already given this top equation f of x, so he's going to give this one g of x. Like he said, it's just kind of like giving it a different name. Instead of y equals, we're going to just say g of x equals. Instead of y equals up here, it's f of x equals. You could write it either way.
You can kind of make a distinction between the two equations. If I'm talking about f, I'm talking about this one. If I'm talking about g, I'm talking about the second one. From there, you can just talk about evaluating a function. So suppose I use these two equations that I have here. If somebody said find, say, f of 4, well, all I do is I find my f equation, and everywhere there's an x, I just plug in simply the number 4, and then I simplify it down. So 4 squared...
What would I get for an answer here? F of 4 equals, what is 4 squared plus 4? 20? Because what's 4 squared? 16 plus 4?
Is 16. 16 plus 4 is 20.
Nice job.
So you could say that f of 4
High fives going on
20.
in the audience. Good.
Likewise, if they said calculate g of 4, well, g of 4, again, I just find my g equation, and everywhere there's an x, I replace it with the number 4, and then I just simplify it.
Okay. All right. Did good on the last one. What's this one? Say it louder. 27? Agree? Let's see.
Down. So 8 times 4 is 32. 32 minus 5 is 27.
Woohoo! 2 for 2. Function notation. It is an equation written in function notation, uses f of x. Remember, not f times x. It's f of x to represent the output of the function f for an input of x. All right, let's do some practice. Example number 1. We want, they say, let f of x equal 2x minus 5. There's our equation. They want us to find f of x when x is a negative 3. And then they say find x when f of x equals 13. So there's 2 problems there. They want us to do 2 problems. The first one, here's the equation that we work with. The first one they want us to work with is finding f of x. So find f of x. Find f of x when the x is a negative 3. So they don't want us to put the negative 3 in for the f of the x. They want us to put it in for where the x equals a negative 3. So every place there's an x over here. So 2 times a negative 3 equals 5. So function of x, f of x will equal what? Order of operations, 2 times a negative 3 is? That turns into a negative 6. Negative 6 minus 5 is? Negative 11. There's the first answer of what they were asking us when they said to find f of x when x is a negative 3. Now the second part, they say, and then find x when f of x is 13. So am I going to put 13 in for f of x or x? Right. They want to know when f of x is 13. So I'm going to put 13 in for the f of x, because that's going to be equaling with 13. So now we solve what we have. So what do I have to do to both sides to solve this? Now I have 13 equals 2x minus 5. What do I do? Excellent. I have to add 5 to both sides. Plus 5. So now what do I get here? I have 18 equals 2x. And now what do I do? Divide both sides by 2. And what do I get? 9 equals x. So if f of x, if this was 11, my x would have to be, or excuse me, 13. My x would have to be 9 for that to work out. Questions? So on your worksheets today, just make sure, am I supposed to put it in for the x, or do I put it in for the f of x? You're going to have to make sure you know which one to put it in for. All right, so let's practice here. Here we're using the same, instead of f of x, we're using g of x equals a negative x. I like to use the parentheses as you do, remember, plus 7. Again, g of x, we're using the same equation in both problems, equals a negative x plus 7. Now in this first one, solve g of x when x equals 4. Where do I put the 4 in? Do I put the 4 in here to the left side, or do I put it in the right side? Which one am I going to put this 4 in for? Which one? Who says the left? Raise your hand. Who says the left? I just seen who's away. Who says the right? Good. Because it just says the x. So we're going to put it in for this one. So let's find g of x. If x is 4, what is my answer? What did you come up with? Annie, what do you get? So g of x equals what? Negative 3? Final answer? No? What do you get here? What's negative times a positive 4? Good. What's a negative 4 and a positive 7? Is it a fight or no fight? Fight. Who wins? Positive by how many? 3. So g of x equals 3. Now number 2. We want to find x when g of x equals 9. Do I put 9 into the left or to the right? Left. Good, because it says g of x, so we're going to put it in. And that doesn't mean we write g times 9. We don't do that. The g of x, that's your whole function, so it's just you substitute it in for the whole thing over here. So 9 equals negative x plus 7. What's the first thing I do to solve here? You
take subtract 7.
She says subtract 7. I highly agree. So what do I have left over here? 2 equals, yes, a negative x. Done, right? Right? Don't agree with me all the time. Right? Wrong. Why am I not done? What do I have to do, Alex? So what do I do if it's a negative? I can't have a negative variable, so what do I do? Divide by what? Negative 1, because we have that assumed 1. Good memory. So x equals 2 or negative 2? Negative 2. Done. Pretty easy. Pretty easy. Now we can take this into the graphing mode. I'm going to slide this over. Oh, there's my answers. No peeking. There, I fixed it. They want us to take this equation, f of x equals 5 over 6x minus 3. Now remember, we just said that's kind of another way of naming it. F of x equals 5x minus 3. Is that in slope-intercept form or function form? Kind of. What are we missing? The y. So what do you suppose we could rename? How could we rewrite that? That's all we have to do. It's that simple. Instead of f of x, it's just y equals 5, 6x minus 3. Don't even have to rearrange it. We just renamed it, give it the y back again. Now we can graph it. How do you want to graph it? Do we want to use zeros? I wouldn't. Why wouldn't I want to? Because it's already in slope-intercept form. I don't want to use the t-chart. This looks so easy. Where do I start on my graph? Where? Can't hear you. You guys are all so whispering today. Or either that or I got too much earwax. Where do I start? Oh, that's better. -3. So that is down. Where do I go from the origin? Right? Up, down, left, or right? I'm just going to go here. So we're going to go to the -3. And our slope is a positive, so when we're done, I hope we have a positive line. So from my slope, do I run left or right 6? The bottom is 6, so I go left or right 6? Right 6, and then what?
Up 5.
Brilliant. So go right 6, up 5, put a dot. What if I wanted to go backwards from here? What would I do? Left 6, down 5. I could if my graph was bigger and I'd end up with something down there. You use your straight edge, graph that function. Easy. Okay, rewrite them and graph them. So here we have g of x. What do I write that as? And you do have to do this as easy as it is. You have to rewrite this for points on your worksheets and your quizzes. It's like Merry Christmas. I'll take simple points like this anytime I can get them. How would I rewrite this, Keely?
Y equals 2 or -2 over x plus 2.
Okay, and how would I rewrite this one, Alexi?
I was behind.
How would I rewrite it?
Y equals 2 over 2x minus 1.
Yep, thank you. All right, so go ahead using the slope-intercept form. You don't need t-charts. You don't need to substitute 0. You don't need to rearrange. I'm tired of graphing. Who wants to graph the first one? Number 3, who wants to graph it? Come on up. Thank you. And you can pick whoever you would like, anybody in here, to do number 4 since you volunteered. And your little arrows at the end. And now does the class agree? Looks like she started at the 2. Well, she has a negative slope. That's good. And that's heading in the negative direction. That's a bonus. So she started at the 2 on the y. Right there. That's good. And then she ran +3 and down 2. 1, 2, 3, down 2. Perfect. Or how about if she were to put another dot? How can I do this backwards? Left 3, up 2. Exactly. I'll just add another dot. Left 3, up 2. Right there where her line would have gone through. You can pick anybody you want. Thank you. Good job. Number 4. Who wants it? Ooh, everybody's hiding. Who is she going to get? There we go. And the next student is starting at the -1 on the x. You want to start at the -1 on the x? Is that where you want to start? You really want to start at the -1 on the x?
Oops. No.
Hint, hint. Do you really? Oh, there we go. The -1 on the y. Much better. You're running 3 and up 2. Is that what you want to do? No. What do you want to do? You want to run to, what are you going to do now? I'm so confused. Help me. What are you doing?
Running 2 and up 3.
Oh, running right 2 up 3. There we go. Now do we agree? That was a good pick. Thank you. You just did that on purpose for learning reasons, right? You just wanted to see if you were paying attention.
Definitely.
All right. Alrighty, let's see. I think we're going to skip this part if we have any of those on our worksheet. However, we do want to work with the formula. Who knows the distance formula? You guys remember that? Like if I'm driving this fast and it takes me this long, how far did I go? Or if I went this far in this amount of time, what was my rate? Here, write this formula down then. Distance equals rate times time. That's it. Find the distance. You take your rate times your time. How can I rearrange that? I mean, if they give me the rate and the time, well then I just multiply them. But what if they give me the distance and the time? We're good at rearranging this equation. How else could I write this equation? Like T equals RD? Would that work? How about if I wanted, because this means times, what's the opposite of R times T? R divided by T. So if I were to divide this all by R, that would leave me with T equals D divided by R, right? Wouldn't that be the same? Or you can do what I've taught you in the past. Instead of, if you don't want to rearrange it, just pluck the numbers in that they give you and solve for the missing one. That's usually the easiest. Let's see what they give us here. You ride your bike at the speed of 12 miles per hour. Use function notation to write an equation giving the distance traveled as a function of time. How long will it take you to travel 30 miles? Let T be the elapsed time in hours since you started riding your bike. Let the distance, T, function of T, distance of T, distance traveled in miles at that time, write a verbal model, then use your verbal model to write an equation. How do you want to start it? I'm seeing some confused looks. Just think of what we just did in our notes and let's try to put an equation together using that. We want to know the, in words, we want to know the, what's this? Distance what? We want to know the distance, right? Traveled. That is going to equal, what did I just give you in that formula? The speed of the what? What is this? What are we talking about? The speed of the bike times the, what is this? Time. So you have your D equals speed, this is your R, how fast, the rate, the speed you're going, times your time. So you have your D. See how that works? All right, so down here, find the value. Well, so we read our equation. So we have our function, the distance and time equals what? What do I want to put behind it? What else do I know? Give me another number. Because we know our distance. Our distance equals RT, right? Let's plug in our numbers like we talked about. Do we know our distance from our information up here? We have these two numbers. We went 12 miles per hour and we went 30 miles. So where am I going to plug those numbers into? Where is this 30 going to go? Is that going to be my distance, my rate, or my time? Yeah, that's the distance. We traveled 30 miles, so 30 miles will equal, well now rate or time. Does 12 miles per hour go for the rate or the time it took us? The rate. So we're going to have 12 times t. How do I solve that? 30 equals 12t. We're down to a one-step equation. What do I do to both sides? Divide by 12. So the time it took us to go 30 miles at 12 miles an hour is what? I see some calculators going. The hamster's running in the calculator above here. What is 30 divided by 12? 2.5. 2.5 or 2.5, either one. And I have to label that. It took us 2.5 what? Minutes? Light years? Oh, hours. Took us 2.5 hours on our bike to go that far. All right, so for today, if you come up with a distance, just remember this formula right here. Plug in the two numbers they give you to figure out the one that's missing. It's just like in our Friday packet when we do the area equals length times width times height, or whatever the formula was. They give you all the numbers but one. Find the missing one. Okay, your assignment is the worksheet 8.7, front and back.